Have you incorporated artificial intelligence into the solutions you provide?
We have done some AI, not any artificial intelligence as far as, robotics, so to speak, but AI as far as vision detection and machine learning. We're training the vision detection capture to identify a truck. What kind of truck? Is it a box? Is it a trailer? Is it a container? What kind of container? A chassis. We're trying to do facial recognition of vehicles. So, we talk about people facial recognition and unique features. Every truck has its unique scratches, dents, decals, and they don't change from day to day. That's what they are. And especially around seaports, this is really important because you may miss a vehicle license plate. You may not capture all the numbers, but if you capture all the features that are within your AI database about that particular vehicle, you can pretty much guarantee who that is.
These different detection systems do capture data, though, and it's really important data.
Oh, that has become one of the most important things we're doing now in the industry. It used to be that the most important thing was to understand where cars were in order to transition that intersection. There's different phases. Think of the moon phases, but there's different phases to an intersection. And some of them are left turn phases, through phases, all of these different things. And they have to all work concisely so that you don't have opposing phases on at the same time, because then you'll have an accident. So what we've done now is that's still important, but what's now more important is all the data that we get out of there. How many vehicles an hour are coming to my intersection? At what direction, which part of that intersection are more vehicles coming, so that we can make sure that the timing is correct? Because a lot of times these intersections are not just standalone intersections. They're interconnected to multiple intersections, a whole corridor of intersections. So when you mess up one, you mess up the entire corridor. If you've ever driven down a road and you get a red light and then you get to the next signal and it just goes red, you know they have not timed that corridor properly, or something's out of sync.
As it relates to the traffic industry, what would you say is the biggest benefit of radar technology with vehicle detection? And then what do you think is the biggest opportunity with radar moving towards the future as well in the industry?
So there are a couple of very important things about radar that are not necessarily provided in other sensors. I'm going to mention two of them. One of them is definitely the high performance in bad weather conditions compared to other sensor modalities. Basically, in cameras, you can see that the performance is different during bad weather or at night condition. Similar situation for LiDAR, but radar has this significant advantage. And one very important thing that in countries like Europe you are going to see them is that radar provides privacy compared to camera. So when you get the radar data, there is no way that you know who is the person behind the car. So if you don't want to know this, you will not know this if you are using radar. I think in future this will become a very important part of the competition, basically.
I was just thinking it's a lot like adding brains to an intersection, right? Like it makes it so much more intelligent and adaptable to what's actually happening, because as good as the traffic engineers are, it's constantly changing. It's never static, and as soon as they optimize something, it changes again, because now people are like, well, it's quicker for me to go this way, right? So without that detection, like how often can a traffic engineer actually get to retime a corridor? So that adds so much benefit to the traveling public in general. It's just being able to see what's going on and adapt to it in real time.
But yeah, I estimate that I probably have designed probably 1,000 intersections.
Wow.
In my career. Yeah.
Yeah.
Some, very easy and some, definitely more difficult, but yeah, I've done a lot of signals.
So when people come up to you, they say, "Hey, signal gal," or certain people?
No, not too many people know
Okay.
that, unless they maybe, read a proposal. But yeah, I guess some people will kind of
Yeah.
nudge me with
Signal
that.
Yeah. I'm curious. I mean, you've seen so much technology over
Yes.
your time come and go. What do you think is here to stay? What's gone by the wayside over the years?
So Wavetronics
Yeah.
is here to stay. Love.
You don't have to say that, but we appreciate
I know, but really, you guys have really changed my design side of things. Way back in the day, again, I have 30 years experience, but loops were cut in the road. And so when construction happens, then you got to cut in new loops. Well, now today, we just go in the cabinet and redraw out the little area, and voila, we've added a second left turn lane, we've added another through lane, whatever it is. Wavetronics makes it very, very adaptable to make changes very quickly.
In this creation of what happens with Wavetronics and vehicle detection, how does radar play into that?
Wavetronics comes onto the scene trying to solve traffic problems, right? In a time when they're cutting loops in the ground where you have to cut one for each lane, right? And for each zone that you want to detect in, you have to have your own loop. And then there's cameras coming onto the scene at the same time, but they're struggling in low light and high light, right? In twilight, right? In the dawn and in the dusk, because they have to change algorithms somewhere in between there, and there's not something good for the crossover point. Weather is a problem. And so Wavetronics comes onto the scene using some of this, coming out of BYU, right? David Arnold and Mike Jensen have labs there where they're developing radar with their students and realizing that this can be used to detect vehicles and make these problems a lot easier to solve. And so that's allows Wavetronics to come in and really disrupt the industry, right? Create these devices that are easier to install, perform better in some difficult conditions, and really revolutionize how things were going.
Is there something common that you see a lot?
Yeah, it's poor design and poor installs. So it's amazing how this technology gets installed the wrong way. So we can come in and the state will pay a contractor to go in and install a unit, and immediately we'll get called in to adjust it. So that's pretty cool.
Do you start getting those jobs on the other side sometimes because they see what you've done to finish someone else's poor work in that regard?
Nowadays, we get on the front side.
Okay.
So we will get that initial contract, and we've built a reputation of we install it once and we don't touch it again because it's done the right way.
They wanted to know how well we worked in the winter. And that's a big thing in our industry. And this time, our coldest installation, I think, was somewhere in Alaska. And so beforehand, we had Dan Dukewitz, love that guy. He actually made a video for me where they froze a sensor in a block of ice. And then they tested it, and it worked just fine. And I remember when I showed it to the people in Kazakhstan, we went and we showed it to not just we were still vetting our dealer at this time, but we showed it to a bunch of government officials. And I just knew that this would be the cherry on top, right? Here it is, we've frozen our sensor, and it's like 4 or 5 inches worth of clear ice on front of the sensor. And we throw it up and it works. you know, the kind of eyes glaze over and whoa, and this main guy, his name Talgat, he says it really works with that thick of ice. I said, well, that's what it looks like. He says, yeah, because we get ice that thick here. And I thought he was joking, and he was still a little tongue-in-cheek. Anyway, sure enough, they get a bunch of ice on their sensors there. But the beauty is that we work, and that we've worked really well for them.
And when we talk about radar and traffic, there are different aspects, different products, and different applications of radar. Explain that to me. I mean, there's highways and there's intersections.
Right. So on highways or freeways, you're really trying to measure. I mean, first it's counting and classifying and measuring speed, and DOTs submit reports to the FHWA, and that rolls into funding based on how many cars are out there. But also understanding the demand and all your trip time signs, 30 minutes to the airport, 60 minutes to the airport, all those things are based on what the traffic flow is at the time. And so speed is important. And then when you pull in ramp metering, where you're saying, hey, let's not overload this freeway, then it can be pretty important to have fairly accurate speed and occupancy of the road, or how much of the road is occupied. And so detection using radar can answer that.
And then getting into the intersection, there's still multiple products for intersections, right?
Yes. So in intersections, again, you have loops, and you have video, and probably a myriad of other technologies. And there, the application or what the product needs to do is first communicate to a controller when there's demand. When there's someone at the stop bar, oftentimes they'll want to know if they're 4 cars back, or how big the queue is, those type of things. And then the other feature that is common is advanced, I want to say preemption, but advanced detection, where if you're detecting a vehicle coming to an intersection, you want to hold the light green when they're in what's called the dilemma zone, which is defined to be like 2.5 to 5.5 seconds. And when someone's in that zone, it's hard to predict whether they will go through or stop. And which is fine if it's just a single car, but if there's someone behind them and they think they're going through and the car in front of them thinks they're going to stop, then you have a conflict. And so it's safer to wait to transition to yellow or amber when those zones are clear.